Hello guys, today I'd like to tell you about navigational aids. I hope you enjoyed this information and I'm sure you'll remember everything you need, and you must, of course. I will try all my best to make this process easy and affordable for your understanding. Navigational aids. Radar beacons are used to help a pilot navigate along airways and to help controllers keep accurate track of his progress in relation to other traffic when no radar is available. They also provide holding in a particular area, locating an aerodrome, or may be used as a fix for a let-down procedure in bad weather. Certain other aids are used for long-range navigation and landing approaches. The first point, non-directional beacon, NDB. This most basic of all aids is still used in less developed areas to mark air routes, its useful range being up to 100 miles. It remains the most common approach and landing aid, sometimes referred to as a locator beacon, with a range of about 15 miles in this application. The NDB consists of a radio transmitter in the medium frequency band, which sends out a continuous steady signal in all directions. A call sign of 2 or 3 letters in Morse code is superimposed at regular intervals as a check that the desired beacon has been selected. The automatic direction finder, or ADF, or radio compass, fitted in an aircraft when tuned to the appropriate frequency, indicates the relative position of the transmission source by a needle on the radiomagnetic indicator, RMI. Unfortunately, NDBs suffer greatly from interference. Their signals can be deflected by high ground and coastal refraction, and if there is a thunderstorm in the area, the needle may point to its most active cell. Still, NDBs have one advantage. This advantage is that their signals follow the curvature of the Earth, so if the aircraft is within the power range of the station, the signals can be received regardless of altitude. Very High Frequency Omnidirectional Range, VOR. For the last 40 years, VOR has been the AAYA standard international short-range nav aid, used both to navigate along airways and to provide an accurate approach. It consists of a ground beacon which sends out a signal from which an airborne receiver can determine the aircraft's bearing, or radial from the beacon. The receiver can add 180 degrees to the from indication and instruct the pilot which way to fly to the station. A to from flag on the instrument face tells the pilot in which mode it is operating. Accuracy is increased by the addition of Doppler, DVOR, by which fluctuations in frequency wave motion emitted by an object moving at speed can be calculated. VOR's great advantages are ease of use and freedom from static interference. With 2 VORs, an accurate fix can be obtained from radio intersections. VORs can also be used for adding broadcasts. Disadvantages are that the very high frequency signals are line of sight and thus can be cut off by mountains and man-made obstructions. For the same reason, a large area of coverage requires numerous expensive beacons. Distance Measuring Equipment, DME. DME gives a pilot range information from a DME facility, which in case of en route aids is normally co-located with a VOR. DME is also coupled with instrument landing systems, which makes fixed ground outer and middle marker beacons unnecessary. A special transmitter in the aircraft transmits pulses in all directions which are received at the DME ground station. As each pulse is received, an answering pulse is transmitted automatically, and this is picked up in the aircraft. As the speed of radio waves is constant, a computer in the aircraft which measures the time interval between the transmission of the pulse and the reception of the response is able to convert this interval into a distance and display it in nautical miles or kilometers. With more advanced equipment, the time to go to the beacon can also be displayed. Because DME measures slant range rather than ground distance, an aircraft at 30,000 feet overhead the facility will get an indication of approximately 5 nautical miles. Combined with VOR, DME provides an extremely accurate position fix. Instrument Landing System, ILS. ILS gives pilots a continuous indication of whether the aircraft is left or right of the final approach track, and also its position in relation to an ideal glide path to the runway. This information is provided by marker beacons, the outer marker at about 4 miles from touchdown and the middle marker at about 3,500 feet. As the aircraft passes over them, they give an audible signal. The outer marker transmits low-tone dashes, and the middle marker alternate dots and dashes on a medium tone. These markers can not only be heard, they also illuminate lamps on the instrument panel. These signals are transmitted on a standard 75 MHz. A transmitter with a large aerial system known as the localizer is situated at the far end of the runway, transmitting its signals on either side of the interline of the runway and approach. A second unit, the glide path transmitter, is located at the nearer end and slightly to one side of runway. Aboard the aircraft there is an instrument with 2 needles. One is actuated by the signals from the localizer and moves left and right, while the other, which is operated by the signals from the glide path aerial, moves up and down. When the 2 needles are crossed at right angles, the aircraft is lined up for a landing. Any deviations can be quickly corrected by an experienced pilot. ILS are divided into 3 categories. Cat 1, operation down to 60 meters decision height, with runway visual range RVR of 800 meters. Cat 2, operation down to 30 meters decision height, with RVR of 400 meters. Cat 3, operation with no height limitation to and along the surface of the runway with external visual reference during the final phase of landing with RVR of 200 meters. Localizer DME approaches are non-precision and therefore uncategorized. Omega 8 VLF, very low frequency radio transmitters, are situated at strategic points on the globe: Argentina, Australia, Japan, Hawaii, Liberia, North Dakota, Reunion Island, and Trinidad, so that aircraft equipped with a simple receiver and Omega charts can find their position wherever they are. Omega is a very long-range form of LoRaWAN. Global Positioning System, GPS. It is generally considered that GPS is revolutionizing aircraft navigation now and will in time replace most existing aids. Based on a series of satellites, it is capable of fixing an aircraft's position anywhere on the globe with an accuracy of few meters. It is already under trial on certain transoceanic flights and may become the major aid for instrument approaches during the next few years. GPS was originally designed for U.S. military use, the first satellite being launched in 1978. The completed system consists of 24 satellites with 3 autonomous pairs. The master control station is located in Colorado and is supported by monitoring stations on Ascension Island, Diego Garcia, Kwajalein, and Hawaii, spaced at nearly equidistant points around the Earth. The satellites require constant attention from the ground, including orbital position adjustments. Without this maintenance, it is said that the system would degrade in about 2 weeks. GPS equipment in the aircraft measures the time that it takes the satellite signal to reach the receiver. To do this accurately, it needs the exact time the signal leaves the satellite. Each satellite carries 4 atomic clocks to keep unbelievably accurate time. GPS works on the classic navigational principle of triangulation. However, instead of the position being the point at which 3 lines from different radio beacons intersect, a GPS position is derived from the intersection of 3 circles transmitted from 3 satellites. the receiver also checks a fourth satellite. Also, operational is developed GLONASS, the Global Orbital Navigational Satellite System by Russia. A joint system combining the GLONASS and GPS satellites is planned so that worldwide coverage will be increased significantly. For detailed information, read the text again and answer these questions, guys. The first question is, what is the function of radio beacons? The second one, what is the purpose of NDB? The third one, what can you tell about advantages and disadvantages of NDBs? The fourth one, name the two main components of VOR. Number 5, how is the VOR accuracy increased? Number 6, what kind of information does DME give? Number 7, when does DME provide an extremely accurate position fix? Number 8, what is the function of ILS? Number 9, name the two main units of ILS. Number 10, how many categories of ILS can you name? How do they differ? Number 11, how many omega transmitters exist? Number 12, where are they situated? Number 13, why has Global Positioning System got this name? Number 14, how many satellites make up the system? Number 15, what is GLONASS? So guys, now I would like you to have a look at this exercise, get familiar with all the details, and get ready with your answers. So guys, you've just listened to vitally important information about navigational aids, and I wish you good luck.